Welcome to the Introduction to Programming series. My name is James, and today I'm going to be talking about arithmetic and other things that are quite useful when dealing with math inside of code. First, I'm going to recap on data types. Hopefully, this clarifies some of the questions I usually hear, and just gives you another pass on what we talked about in the last video. I'm also going to talk about, or 2 videos ago, I'm also going to talk about arithmetic. That's the bulk of what we're going to talk about today. And then I'll mention something about types and mixing types. You'll find out that when we're doing math, we have to use the same type of variable, the same type of value, and we can't mix and match. There is a way to mix and match, and you have to convert things, but I'll show you about what that means later. But for now, let's get started with data types. All right, so there were four basic data types as a reminder here. You guys may remember there's integers, floats, strings, and booleans. Integers are whole numbers. They can be positive, they can be negative, but they have to be the entire number. They can even be 31 million or more, right? They can be huge numbers, small numbers, all this stuff, but they have to be whole numbers, no partial numbers. Floats then allow us to have partial numbers. They can still be whole numbers like 1.0, right? That's still a float, but it can be more precise than that. It can be 1.2 or 0.123 or 0.5995, right? All this stuff with precision we can have is with floats. Strings then are letters, words, or sentences. These are anything we want to say. We actually can put numbers inside of strings, but you'll find out that you can only do math, like addition, subtraction, multiplication, division, with integers and floats because they're numeric data types. You can't do math when it's a string. So you could put like double quotes and then the number 101, but it wouldn't be able, I couldn't do math at that point. It would just be the word 101, if you will. And then Booleans, probably the easiest ones to think about, but they're true and false. It's hard to find out when they're useful, but we've seen some in some code along examples, but they're just true or false. And then we didn't really talk about this directly, but just to show off, how do we refer to these things in code? When we want to deal with variables that are integers, we use int. Want to use variables that are floats, we use float64. Strings is string, that's nice. And then booleans is bool, a little bit shorter. So this is what happens when we want to deal with variables in our code or refer to these data types. Another recap on the expressions. As a reminder, expressions are values or anything that turns into a value. So 2 plus 3, x times y. These are 2 is a value. 2 plus 3 is an expression that evaluates into being a value. But all of these are expressions. So if we're ever restricted to using an expression somewhere, we can use any of these, either values themselves or things that become values. Variables then are the other side of things where we want to store values. X is a variable that stores the value 2, right? 2 gets put in the box with a label X on it. And then when X is used later, X times Y, it goes to the box, it sees what's inside of it, currently 2. Y would get 5, so it'd be 2 times 5. And then that 10 gets stored in Z. So variables are these things that hold on to data that we can use later or mess with, modify. And how do we want to modify them? Well, often arithmetic. We want to do some sort of math. A lot of this is going to make sense. Some of this is going to be a little bit weird. We use a plus sign for addition. That's great. We use a minus sign for subtraction. That's great. Both of those are up on your keyboard next to the backspace button. One's shift, one's not. And then this is where it gets a little bit different. When we go to multiplication, often when we're learning math, we use an asterisk. Oh, sorry, we use a lowercase x, like 5 times 7, or we use a dot, like a solid dot. When we're using programming, we like to use the small x for something else, and we don't really have a solid dot anywhere on the keyboard. So we use an asterisk. Asterisk is how you multiply numbers in code. And then the same thing for division, we use a forward slash. Now, a couple of videos ago, I talked about backslashes for formatting things like \n, \t. That's when it leans to the back of the sentence, the beginning, versus a forward slash is when it's falling forward. It's going from bottom left to top right. And that forward slash is also next to backspace, sorry, the shift key you've got on your keyboard. So see if you can find these on your keyboard before we move on. And then I also want to mention this weird one at the very end, the percent sign. This throws off a lot of people. It threw me off for a while. But I promise once you unlock the secrets of what's cool about this guy, you can do a lot of really cool things in code. This is called modulo or modulus. And this is a remainder thing. So what this will do is after we divide something, if we have any leftover amount that didn't make it into the integer, this will give us the remainder. So I'm going to go through examples with all of these. Let's get started with addition. For all these slides, we're going to assume that these variables existed. I created them already, and then we're just going to kind of jump in and work with them. So looking at this first line, x equals 5 plus 1. So as we know with programming, the equal sign is sort of a do whatever's on the right side, evaluate it, and then put the value on the left side. So the right side, 5 plus 1, is what? 6, right? So 6 gets stored into x. And that's it. X is just now a variable that has the value 6 in it. We can change it, which will replace or overwrite the 6. But for now, it's just 6. And then I can use it in another line, the following line. Say, hey, x is 6, right? So this is 6 plus 4. It'll go and figure out what value x currently has. It'll extract the 6. It'll make it 6 plus 4, which becomes 10. And then 10 will get stored in the y. So y will now be the value 10. Y is a variable that stores values, and it's currently storing the value 10. And so then that, we can continue. We can say x plus y, which just says, okay, well, what's x? X is 6. Y is what? 10. So 6 plus 10 is 16. So z is 16, right? So it does the right side of the equal sign, and it calculates a value, and it places the result into the left side of the equal sign. That's what's happening with these single equal signs. And then we got some cool things we can do. This one's not really that funny because all it does is it takes x, which is currently a value of 6. It takes the 6 and it places that in x, which makes x equal to 6. It doesn't do anything, right? Kind of a waste of a line. This one's cool. Y plus 1, because what we're doing here is the right side evaluates and then it puts the value on the left. We can do cool stuff like this. Like, hey, let's take the 10 out from y. Let's add 1 to it, and let's store the resulting 11 back in y. So 10 plus 1 is 11. 11 gets stored in y. And this one's interesting. Z plus z equals z. So it's going to take 16, add it to 16, which is 32, and it's going to store 32 in z. Right? Kind of getting the hang of it? Cool. And if not, rewatch it and keep following through these practices. The next one, subtraction, right? So 4 minus 1 is what? 3. So it takes that 3, it places it in x, and so x is now 3. 3 minus 8, right? 8's bigger, so 3 minus 8 is going to be negative 5. It's going to take that negative 5 and store it in y, and so y is now negative 5. And then the same thing happens, x minus y. X is 3, y is negative 5, so 3 minus negative 5, remember the minus and negative makes it a positive. 3 minus negative 5 is going to be 8, and then 8 is going to get stored in z. And you can do this in code if you want, and prove it to yourself as well. And then the fun ones, x equals x, yep, that doesn't change. X is 3, but we can use it just like we did the last one, where y is currently negative 5. Negative 5 minus 1 is going to be negative 6. So y would now be negative 6 because it has gone down 1. And this one I think is kind of funny. Z minus z. For any z, it's always going to be 0. What's 23 minus 23? It's 0. What's negative 23 minus negative 23? It's 0. But we can just, again, the right side's happening. It's like a two-step process. It does the right side first, and then the answer, the result, gets put in the left side for storage. Multiplication, x equals 4 times 1. That would be 4. X is 4. Well, we got 4 times 8. That would be 32. So y becomes 32. And then we've got, man, 4 times 32, which I'll give you a second, is, yep, 128. Yep, so far so good. X equals X. X is always going to equal X. So whatever X was gets to be placed in X. Now y times 2. Okay, so 32 times 2 is going to be 64, and 64 is going to get stored in y. Oh my God. Okay, so z times z. So 128 times 128, which is 16,384. And that just puts z inside of, whatever. It takes this, it does the math 128 times 128, and it stores the result into z. Yeah. Speeding through it, we got division. Actually, this has some interesting pieces here, so we actually do want to take our time on this. 16 divided by 2, that is what? 8, right? 8 times 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is easier. That's what? 4. And then 8 divided by 4, awesome, is 2. So division just works. Yeah, it's the left side divided by the right side. 16 divided by 2 is 8. X equals X, always 8, always whatever it is. Now this one's interesting. Y equals Y divided by 6. So Y is 4. 4 divided by 6. So let's see what that looks like. 4 divided by 6, right? How many times does 6 go into 4? 0, right? And when we've learned long division, we could do like, oh, let's make it 40 and 6 into 40, but we're not going to do that. We're just going to say it goes in 0 times. And in fact, if I subtract 0, I get a remainder of 4. So it's actually 0 remainder 4. I don't know if you guys remember remainders. For me, it's been a while. But 4 divided by 6 is 0, right? So this is going to be 0 because you can't fit any 6's in 4. You can't divide 4 six different ways with whole numbers, right? It'd have to be something partial, and we're using integers, so we can't have partial numbers. We have to have whole numbers. Anyway, then on to z. Z divided by z, 2 divided by 2. Yep, 1. For all but there's a single number you can put here to break things, which you'll find on the next slide. But for all other numbers, it's going to be 1, right? Because any number divided by itself is 1. Okay, now the weird one, modulo. So this is interesting. So 16 mod 10. What's 16 mod 10? Well, what it's saying is what's 16 divided by 10. Oops, 10. And let's do the math. Let's do this. So 10 goes into 16 one time, which gives me a 10. And that has a 6 left over, right? And I'm going to do this style. I'm not going to keep on the decimal points because there's no reason to. It's an int. So I'm just going to stop there and say that's 1, remainder 6. Now, the difference was up here, I did 4 divided by 6, and I got 0, right? 4 divided by 6 is 0 because this guy came from here. Down here, I'm doing 16 mod 10, and the question is what I'm going to get. And if I actually run this in code, what it gives me is 6. It gives me 6 because it cares about the remainder, right? When you're doing this percent sign, this mod, different than this divide. When you're doing a divide, you want the main number. But when you do the mod, you're asking for, give me the remainder when you're done. Do the whole thing, whatever. I don't care how many is on the left side. Just give me what remains. What's left over? I want the leftovers. So then if I have, what, 6 mod 4, we actually go back up here, don't we? Oh no, it's 6. It's a different one. 6 mod 4. 4 goes into 6 once, minus 4 gives me 2. 1 remainder 2. So it should be that 2, right? That should be what our mod is. Because we don't actually care about the left side, we care about the remainder. And let's look at this one. Let's see if we can do this one in our head. What is 6 mod 2? I'll give you 5 seconds to think about that. Feel free to pause it now if you want more time. Yeah, 2 goes into 6 3 times with a remainder of 0. So it's actually just 0 because there's no remainder because you can divide it evenly. So our fun side, yep, x equals x, never changes. But now we've got y equals y mod 6. So 2 mod 6. Think about that. What is that going to be? What's 2 mod 6 going to be? Well, how many times does 6 go into 2? No, no times, which means you just left with the remainder of 2. It doesn't change it. And then z mod z. So what is that? 0 divided by 0. And if some of you have been warned, you can't divide by 0. We can't do that. Programming hates it. So actually what's going to happen is it's going to throw an error. We cannot divide by 0. Yeah. If this was a different number, it wouldn't be a divide by 0 error. But you ought to be careful about when you're doing division or modulo with zeros. Careful, careful, careful about that. All right. That was the long section. Let's jump into a sped up section about floats. Floats have all the same idea, except for they do have the decimal point on the long, right, on long division. You could go all the way as far as you want because we have the decimal point. So we don't need remainders. There's no remainders when it comes to floats because we can actually handle that crazy looking number. So looking at this, we're going to again assume that the variables exist. But 5.02 plus 1.18, what are those? That adds up to what? 6.2. So 6.2 or 6.20 is going to end up in x, right? 6.2 minus 4.09 is close to this. I think it's 0.211. Yep. Wait, 2.11, sorry. 2.11. Yeah, that makes sense. Oh man, and then I'm not going to do this in my head, but 6.2 times 2.11, very simple, just how it works. But if we do that, we draw it out and do the math, it ends up being 13.082. Makes sense. And then if we divide x, okay, so 6.2 divided by 3.1 should just be 2, right? Yeah. And this will be 2 or 2.0. I think I probably should put 2.0 here because it doesn't drop the 0.0. But yeah, it's 2. Right? That's what we get when we divide 6.2 by 3.1. So all those things work the same as they always would. And a tricky one that does come up though is strings. Now strings are actually the most interesting because they are double quotes. You can put whatever you want in them. You can put numbers, you can put letters, you can put words. The downside is they only support the plus sign. All you can do is smash them together. You can put 2 words and add them together, which does something called concatenation. And all that does is it says, hey, these are now 1 word. And so if we want to do something like hello world, I could make a variable hello. I can make a variable world, and then I can add them together. And in fact, what I usually like to do when I'm adding 2 words together is I add hello plus double quotes with a space. This is a space in here. You can't see it because it's just a space, right? And when I do that, then I get hello space world, and it looks pretty cool. But the plus sign's all that works. That's the only one that strings can do. So the good news is strings can hold anything you want. The bad news is they can't really do much. For you to do something with them, you'd have to um, convert things to more useful variables, and that's kind of hard. It's hard to go from a string to a different data type. It's easy to take anything and turn it into a string, but it's hard to do from a string to a data type. And with that, I want to mention this last little piece here, which is typecasting. So typecasting is what we do when our variables are different types, but we still want to combine them, right? If we've got a float, which is 16.5, in integer version, it's a 16, right? We can force it into something. But let's say I wanted to add, like, let's say I wanted to add, I don't know, where's some code? Let me get some quick code out of here. I know I'm surprising you guys with this. Make a math folder. I'm gonna open that. I speed run this main.cpp. Oops, wrong language. A lot of these things are very similar cross programming languages. All right, just like that, we've got that running. Terminal, go run main. Okay. So I can have a variable like um, my number, give myself a variable, var some number. And let's say my favorite number is 14. I don't know. So if my favorite number is 14 and I run it, okay, cool. Now, if my favorite number was 14.5, then I would need a float 64 for that. And it'll show 14.5. The trick is if I want to do math like, let's say I was going to a store and I'm buying some cards, and I want 20 cards, and let's say that the card price is 2.78 per card. So I want amount of cards. So when I'm getting this 20 cards at a price of they cost card price each. If I want 20 cards and they're 278 each, I want to do math to get my total. So if I want my total, it's going to be a price, so I want it to be a float. The tough part is I want my price to be the amount of cards times the card price. But we can't do this. And let's get rid of this one because it says this is not declared and not used. So I can say your total is. All right. So if I have amount of cards and card price, it doesn't like this because what? It says mismatch types int and float 64. It's an invalid operation. We saw how to multiply two integers. We saw how to multiply two floats. We did not see how to multiply mismatched ones. And the shorter answer is you actually can't do that. You cannot mix and match types. If you have different types, we need to change them if we want them to put together, right? So what I can do is I can say, hey, I know amount of cards is that we'll say, hey, I know card price is a float. For this calculation, I want it to be an int. And I guess I would go the other way, right? Is I want the card price as a float and the amount of cards is an int. So I want this to be a float. I need, because the total's a float, the price is a float, the amount of cards is an int. So I need to turn it into um, the thing that I want. And the way I can do that is I just surround the variable I have with these parentheses, and then I say what type I want it to be, float 64. So I want this integer to be a float 64 for this calculation. Now, what's interesting is it doesn't change it forever. It's a temporary manipulation. This says, hey, I want the integer of amount cards to be a float 64 temporarily for this calculation. And now we know how to multiply a float 64 times a float 64 to get some answer. But I have to forcefully do that every time. And if I say your total is, I can say stuff like that is just over, check this out, int dollars. I can then take the float variables and I can turn them into integers momentarily. I can say I want 20 cards at 278 each. They cost a total of 55.59 to $55.6, which is just over $55. And that's because I turned my 55.6 into an integer. The integer forgot or lost the decimal point at the end, but it just did it temporarily for this line. And so you do need to have this stuff, especially for what we're going to be doing in the next couple of challenges, and the code along that follows. But you have to be able to convert integers and floats between each other. That's the two big ones that we have a lot. So I just want to mention that before we finish today. But um, yeah, there's a lot of stuff learned. So again, let me know if you have any questions, suggestions, or feedback in the comments. If you have any more ideas for the theme spinner I like to do, please put those in the comments as well. And otherwise, thank you for watching. See you in the next one.